So this whole section is about solving the same types of expressions that we've been simplifying for a very long time. So we want to be able to solve rational expressions. Now there's a couple different ways to do it, and I'm going to show you the most common way first, because it's probably the way that most people are going to be looking at it. But for instance, I am going to start out with something where it's just a normal proportion. Everyone knows how to solve a proportion from geometry. So this proportion would be something like 3 over x plus 1 is equal to 9 over 4x plus 5. Now, if we were back in geometry class, how would you solve this? Does anyone remember? You'd just cross multiply, right? You'd use the butterfly method if that's what you wanted to call it, or cross multiplication. So you're just going to multiply one side by the other side, okay? So I'm going to multiply across here and here. So I'm going to end up with 9 times x plus 1 equals 3 times 4x plus 5. And then it's just a normal algebra equation. Now we can obviously make this a little bit more challenging by putting addition and subtraction in the problem. We can make it a little bit more challenging in a bunch of different ways. But I want you to just kind of think about what's happening here, okay? Think about the fact that I'm multiplying this side by x plus 1. I'm multiplying this side by 4x plus 5. Technically, that's what's happening, right? So really, what am I doing in this problem? If you think about it and relate it to what we did on Friday, what am I doing in this problem that's kind of similar to what we did on Friday? Finding common denominators. That's what we're really doing. Because if you think about what's going on, I'm really saying, let's multiply by x plus 1, let's multiply by 4x plus 5. If these denominators are exactly the same as each other, all I have to pay attention to is what's on top. Okay? So that's how I'm going to tell you that I would work through this problem, because it's going to make your life a lot easier in the long run. Okay? It'll give you as little work as possible, which I think is everyone's main goal, is that it's the least amount of work as possible. So just think about what you're doing here. You're creating a common denominator, and if you create a common denominator, then you can just focus on the top part of the problem. You don't have to do a whole bunch of cross multiplication. I don't care which way you do this stuff. If you want to use cross multiplication, that's fine. If not, then I guess do whatever makes you happy. So this is going to be double distributed, which would be 9x plus 9 equals double distribution 12x plus 15. So we've got a normal algebra equation. We subtract 15 from both sides. We subtract 9 from both sides. And I end up with negative 6 equals 3x. So x equals negative 2. Okay? There is one really important thing that you have to pay attention to here, which is actually why we've been spending all the time that we have with these types of expressions. You have to pay attention to what x can't equal. Because if your answer ends up being one of the x can't equal values, then it's not a solution. So up here, remember, we could say x can't equal negative 1, and x can't equal, this would end up being negative 5/4. If either of these matched up where negative 2 was in the same spot as this x can't equal thing, or if any of those were the same values, I wouldn't be able to have that as an answer and it wouldn't work. Since none of these line up, since none of these or these line up, they're not the same, that means my solution is okay and it will work in the equation. Okay? So hopefully this just kind of makes sense. Cross multiplication, just like you always would have, but more commonly what you're going to see is that we make things just have common denominators. So let's look at a question that's a little bit more challenging, but I guess it's a little bit more challenging in the concept of the numbers that we use. Yeah, sure.
So as far as like the equals, so you're probably going to have more, if you had like two groups multiplied by each other, what would the x can equal be? Like say the right side had x plus 1 and the 4x plus 5.
Like this, you mean this part right here?
Yeah.
I guess I don't know what you mean. Because
Yeah.
it doesn't matter. So x can't, or you're asking like what x can't equal, like that part, right?
Yeah, I'm just asking if there's more than one set, because there's one set on each side right now, so it can't equal negative 1 and negative 5.
So it wouldn't matter how many things you have over here. If you would have written 10 different sets of parentheses on the bottom, you have to say x can't equal this, x can't equal this, x can't equal this, x can't equal this. You have to go all the way
So
through
it
and do
doesn't
all of it.
matter.
Correct. You got to do them all.
Wait, so does that mean x also can't equal to -2, right?
No, x does equal -2.
Oh, okay.
Now that means x does equal -2. This equation is only true when x equals -2.
Oh,
Yep. And it's saying that if you were to plug in -1, that would give you an error, which means that one does not work.
okay. So it's like, okay.
Okay. So let's look at one where the math is a little bit different, but the numbers are a little bit easier. So let's say that we have 5 over x plus 7 over 4 is equal to -9 over x. Okay, so this is where I'm talking. I would choose to not use cross multiplication here because it would make my life a little bit easier. If you would like to use cross multiplication, that's totally fine. What you would end up doing is you would combine everything on the left side into one fraction. So if I covered up this right here, if I covered up that -9 over x, yesterday or Friday's stuff would have shown you how to combine this into one fraction. You'd find common denominators, you combine it. Once you combine it, then you can cross multiply. I think that's just a little bit too much work. What I like to do is I like to go through and I like to look at these denominators and I like to try and make those denominators all the exact same. Because if the denominators are all the exact same, then that means I don't even have to look at the denominators, I only have to look at the numerators. So if I have to find common denominators anyway, if I have to go through and find those common denominators no matter what the problem is, I would rather just find common denominators for it all and then be ready to solve my equation. That would be easier for me. You choose however is easiest for you. It doesn't make a difference to me. Okay? So if I go through, I'm looking at the left fraction first, this one right here. What shows up in either of these other two fractions that is not in this fraction? A 4, right? So a 4 shows up here. So I'm going to multiply it by 4 over 4. Okay? What shows up in this fraction that doesn't show up in either of the other two fractions? An x. So I'm going to multiply this one by x over x. Okay? Now we're in a good spot right now because if you notice, my left fraction is over 4 over x. This fraction is over 4 over x. So I already have common denominators here, right? Since I have common denominators, that's a good sign. So then I'm on to my last one, which is this one. What's that one missing? A 4. So I'm going to multiply by 4 over 4. And now if you notice, they are all over 4x, right? So now all you have to do is pay attention to the numerator. That's it. All right? You only have to pay attention to the numerator, which means that I only have to look at this. So I'm just going to rewrite what's in the numerator. So it's going to be 4 times 5, which is 20, plus 7 times x equals -9 times 4, which is -36. So my whole job was to find common denominators. Once you find your common denominators, then you can pay attention only to the numerator and solve the numerator as is. Okay? So now I'm going to subtract 20 from both sides. So then I get 7x equals -56. Divided by 7, divided by 7. X equals negative. Okay? Now the last thing that I would have to check is just to make sure it doesn't line up with one of the problem values. The problem values in this one are x can't equal 0, right? Since those two things don't line up, that means that my solution of -8 is a good one. Yeah?
Why can't it be x equals, or why can't it be 4 there? Since you have the 4x in the
Because it's multiplication, not addition. 4 times 4 is 16,
Gotcha.
so 16 is okay. I can cut a pizza into 16 pieces.
Okay.
All right? So that's how that problem would work. Now, I'm just going to show you the other method of this, just in case you prefer using cross multiplication. All right? So let's say that we had the same exact problem where it was 5 over x plus 7 over 4 equals -9 over x. The other method of solving this, if you're good with what we just did, then you don't really need this method. If you're not good with what we just did, this method might be the better one for you. So this one, I'd multiply this side by 4 over 4. And I multiply this side by x over x, which is about the same amount of work that we did for the last one. We just did one more fraction. This would turn into 20 over 4x plus 7x over 4x, which is equal to negative 9 over x, which would then be the same thing as saying 20 plus 7x over 4x, which is equal to negative 9 over x. And now I'm going to double distribute, or cross multiply. So now I cross multiply here and here. So then I'd be left with something like 20 plus 7x times x is equal to 36x. And then I could go through my double distribution process. So I would get 7x squared plus 20x equals 36x. Yep, thanks. Okay. So then as we go through this process, now I have to set it equal to 0 and I have to solve. So I'm going to be left with 7x squared. I'm going to add 36 to both sides, so plus 56x equals 0. I can factor a 7 out of both sides, and I can factor an x out of both sides. It's going to leave me with 7x times x plus 8 equals 0. And now I get 7x equals 0, and x plus 8 equals 0. So then I'm left with x equals 0, and x equals negative 8. What problem number did I say there was originally? 0, which means this answer and this answer can't work, which means my only answer is x equals negative 8. Now, the only goal of showing you that was hopefully that you see how much more work it is, which it is, right? So if you want to use this method, more power to you. There are people every single year that don't trust me when I say that the other method is easier, and they use cross multiplication every time. That's what you want to do it that way. I do not care. It doesn't change it. The issue is, most of the time that you have this, or that you do this, you're going to end up with one of those no solution things. So most of the time, this is going to end up happening. Okay? So let's go through one more that's a little bit more challenging. That's going to be a little bit more of a problem. So let's say that we have 4x plus 1 over x plus 1 equals 12 over x squared. Okay, so here's the issue. Please make sure you have the same exact mentality that you had when you were combining fractions last week. What was the first step that we took every single time we dealt with any of these fractions last week? Before we even found common denominators, what did we do? Not simplified. We factored it. Keep the same idea. Factor it first. If you factor first, you're going to save yourself a lot of time. If you don't factor first, you're going to create a big issue for yourself. Okay? So if I'm factoring first, I'm only going to look at the denominators. So my left side is not going to change at all. I'm going to leave some room here for common denominators. I have 12 over, and then x squared minus 1 will factor into x plus 1 and x minus 1. This is the difference of squares. And then I'm going to change that 3 into 3 over 1. Okay? Hopefully doing that shows you that it's taking work away. Because now I don't have to multiply everything by so much. Okay? I don't have to multiply every single piece by something. All right? So now if I look, let's go from left to right. What doesn't show up here that does show up somewhere else? X minus 1. So I'm going to multiply this one by x minus 1 and x minus 1. Okay, so now as I look through, I think I'm okay. I think I'm okay. This is still an issue. Okay, this one still is an issue. So what will I multiply this one by? X plus 1 and x minus 1. So I'm going to multiply it by both x plus 1 and x minus 1. Okay. Now, the hard part is over. Now it's just turned into a really ugly algebra problem. Okay. This is the only algebra 2 concept that we have here. The rest of this is just going to be an ugly algebra 1 problem that's going to require a lot of double distribution, foiling, and all that stuff. So I only have to pay attention to the top. So this will turn into 4x plus 1 times x minus 1 equals 12 plus 3 times x plus 1 times x minus 1. I don't really have to do anything with the denominators. The only thing with the denominators is I should probably make sure that I know x can't equal positive or negative 1. Everything else is okay. X can equal positive 1 or negative 1. And now I'm going to go through and double distribute and solve this exactly like I would a normal algebra problem that I would have learned in 9th grade. All right? So I'm going to distribute the first one. 4x times x is 4x squared. 4x times negative 1 is negative 4x. 1 times x is positive x. And then 1 times negative 1 is negative 1. Equals 12. Now, I don't really care how you do this, but I would suggest that you multiply this thing first and then distribute the 3 after. That's what I would suggest because that's what I would do. So I would do the stuff in red first, and then I would distribute the 3 after. So I would get x times x, which is x squared, x times negative 1, which is negative x, 1 times x, which is positive x, and then 1 times negative 1, which is negative 1. Good? You good? Okay. So now I'm going to combine my like terms, which again, combining like terms is just, we're making sure that they are all as simple as possible. So those can combine, which are going to leave me with 4x squared minus 3x minus 1 is equal to, and then the right side, I'm going to distribute this 3 now. So 12 plus 3x squared minus 3x, show up. Actually, we can't do that. Minus 3x plus 3x minus 3. So again, I have more terms that I can simplify here and here. So this is going to leave you with 4x squared minus 3x minus 1 equals 12 minus 3 is 9 plus 3x squared, and then that negative 3x and positive 3x will go away. Now hopefully you can see that it's just a normal quadratic. So with that normal quadratic, we can try to solve like normal. So subtract 3x squared. So 4x squared minus 3x squared is just going to be x squared, and then minus 9, or x squared minus 3x minus 10. So it gives me x minus 5 and x plus 3, 2 equals 0. So then I get x equals 5 and x equals negative 2. The only thing I really have to check is that it wasn't one of those problem values that we had at the beginning. And remember, the only problem values we had at the beginning were plus 1 and minus 1. You can also see how this is a very long, drawn-out process, right? But hopefully, the math behind it isn't that bad. I'm hoping that this is one of those things, you know, sometimes you sit in a math class and you're watching the teacher do it and you're like, man, this makes sense. It really sucks, but it makes sense. I'm hoping that this is one of those things, that it may be drawn out, it may not be fun, but hopefully the math behind it makes sense because it's all just factoring and solving general equations, right? Yeah. How far? Good? Okay. So I'm going to give you one. I want you to try it on your own. See where you end up. All these questions are essentially the same. They just have a little bit more algebra or less algebra depending on problem. So give this one a shot, see where you end up. We'll try to go over it before you guys have to leave. So I'm gonna give you about 2 or 3 minutes. I know that might not be enough time, but I'm gonna try to give you a couple minutes and then I will pick up and try to help you out where I need to. All right, so I'm hoping by now you have either kind of started or you're totally stuck. And if you know where you're kind of at or you know what you're looking at, what you're trying to do, hopefully you're okay. I'm gonna factor first. So I have 6 over x minus 3 equals 8x squared over, this will factor into x plus 3 and x minus 3, difference of squares. Get used to seeing difference of squares if you're not already. Minus 4 over x plus 3. Now I should be able to see that the only thing that we really have to deal with are the left side fraction and the right side fraction. So I'm going to multiply the left side fraction by x plus 3. And the right side fraction I'm going to multiply by x minus 3. I don't really care about the denominators at this point anymore. I care about the fact that x can equal 3 or negative 3. That's about it. So now as I run through this math problem, it's just 6 times x plus 3 equals 8x squared minus 4 times x minus 3. Now this hopefully is a general algebra problem that we just have to deal with, right? Hopefully it's just algebra. So I have 6x plus 18 equals 8x squared minus 4x, and then negative 4 times negative 3 is positive 12. Right? So now I'm going to subtract to make my term, or to make it equal 0. So I'm going to get 8x squared minus 10x minus 6. Okay. So then divide by 2, because I would like to get rid of this. We'll pick up on this tomorrow, I guess. So divide by 2, you end up getting an extraneous solution. But we'll pick up on it tomorrow. Be ready for your test Wednesday.